Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Polynomial Identities in Pascal's triangle. When we're talking about an identity, we're really just talking about a helpful rule. So that's really all that this video is about, is helpful rules or shortcuts. If the shortcut is not beneficial to you, why would you use it? So keep that in mind. So in some of my other videos, we've talked about the difference of two squares. This is an example of an identity. For example, x squared minus y squared is equal to x plus y being multiplied by x minus y. The difference, I'm going to abbreviate that, of two cubes. Okay. The difference of two cubes, like a cubed minus b cubed, is equal to a minus b times a squared plus ab plus b squared. And the sum of two cubes I'll use C and D. That would be C plus D being multiplied by C squared minus CD plus D squared. So the only thing that differs between the sum and difference of two cubes is, yes, there's the minus here and the plus here. That's a minus, that's a plus, that's a plus, that's a minus. So basically these two just flip-flop. Those are all great rules, and if you're ever factoring a binomial or anything else, you should always check for a GCF first. So those are identities that we've learned in previous videos. And again, factoring rules. Try to get to no exponents inside your parentheses. That's your goal. Okay, turn it into a multiply problem. That's actually what factoring is turning it into a multiply problem. For example, 15 factored is 5 times 3. So the number one thing you should do first when factoring is 1. Try for a GCF. Okay? So if I had 5x squared minus 15x, I would say, oh, they both divide by 5, they both have an x. That would leave me with x minus 3. Now it's a multiply problem, and I do not have an exponent inside my parenthesis. Then, second, I would try for a special rule. X squared minus y squared, x cubed plus or minus y cubed. Okay, one of those two. If it has that rule, okay, here we have even powers. Here we have, both of them are a multiple of 3 power. So we could do those rules. So for example, a to the 6th minus b to the 6th. This is both even and a multiple of 3. So I like to do this rule first. And if you come back up here, x squared plus y squared, they split it evenly. One is a plus, the one is a minus. This is a conjugate pattern. Okay, so we will make this a cubed plus b cubed, a cubed minus b cubed. And now you might notice that, hey, that's that rule that we had with the plus power and the minus power. So I'm going to factor this using the a cubed plus b cubed pattern. If you need to, pause it and look back at where you wrote that down. A plus b, a squared minus ab plus b squared. And then this is the same rule, just a minus, so it would be a minus b, a squared plus ab plus b squared. And I happen to know that these are prime. There's nothing that multiplies to 1 a squared b squared and adds to just ab. So anyways, because 1 times 1 is 1, but 1 plus 1 is 2. So that's the answer. This is fully factored. I know there's still exponents in here, but I do happen to know that that is prime generally after you've done that cubic rule. Okay, the other thing that we're going to look at is Pascal's triangle. And why would I even use this silly, silly triangle? So we're going to go over that. The purpose is for a shortcut. If we had to expand x plus y to the 4th. Now, some of you might have just looked at this and said, oh, that's easy. It's x to the 4th, y to the 4th. No, it's not. Okay. xy power of 4 is x to the 4th times y to the 4th, because xy being multiplied by xy being multiplied by xy being multiplied by xy. There's no plus sign separating it. You just count how many x's you have, how many y's you have. But because of the plus sign, you cannot write x to the 4th plus y to the 4th. Not correct. And there is some math memes out there about saving the animals. And one of them says, don't kill the puppies. Save all the puppies. This would have been that error. So what does it mean? I'm going to put a big X to that. We will not do that. That's a common mistake. Avoid it. So expanding it means to do x plus y to the 4th. So sometimes I've told, when I've taught junior high and they've had issues with powers, I said, when in doubt, write it out. So x plus y to the 4th is going to be x plus y times x plus y times x plus y times x plus y. Okay, if you watched my multiplying polynomials video, you would have known that I will group these and I multiply 2 at a time. If I were doing something like 2 times 3 times 5 times 4, I'd be like 2 times 3 is 6, 5 times 4 is 20, and then I'd multiply the 6 and 20 together and get 120. I'm going to do the same thing here. I'm going to multiply these two together. So first, outside, inside, last. Then I'm going to combine like terms. So that would give me x squared plus 2xy plus y squared. Again, that was multiplying these two together. Now, because these two are the same thing, I'm going to get the same answer. And now I have a trinomial being multiplied by a trinomial. So I'm going to use a grid to multiply that out to keep everything organized. A 3 by 3 grid. We have x squared plus 2xy plus y squared, x squared plus 2xy plus y squared. So x squared and x squared is going to be x to the 4th. If you're having trouble thinking about that, think about it written out. It'd be xx, xx. That's why x to the 4th. This would be x cubed y. And this would be x squared y squared. Now I have 2xy being multiplied by everything. So 2x cubed y, 4x squared y squared, 2xy cubed. Now I'm multiplying the y squared. X squared y squared plus 2xy cubed plus y to the 4th. Two x cubed y, 2x cubed y. Those are like terms. X squared y, x squared y squared, x squared y squared, and x squared y squared are like terms. And then xy cubed, xy cubed. Those are also like terms. So I'm going to go ahead and add all the like terms as I put this together. So 1x to the 4th plus 4x cubed y plus 6, because there's a 1 here and a 1 here, right? X squared y squared plus 4xy cubed plus y to the 4th. That was a lot of work. Great. Now I want you to do a plus b to the 7th power. Hopefully you just said, you got to be joking, right? I am. I'm not going to do that by hand. I'm going to use a shortcut. But in order to use the shortcut, I have to teach you the shortcut. Okay. So we're going to go with a side note of Pascal's triangle. And if you want, you can go online, you can Google Pascal's triangle. You will get a very, very nicely, you can find it to a lot of different. This triangle keeps going on and on and on. So the top row is just a 1. The second row is 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. I could keep going. No, I don't have it sitting in front of me. No, I don't have it memorized. I just understand how it works. So we're going to go ahead and I'm going to use pens to highlight your focus so that you can see something here. Okay. If I can get my pens to balance. 1 plus 3 is 4. That's why the 4 is between the 1 and the 3. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 4 is 5. 4 plus 6 is 10. 4 plus 6 is 10. 1 plus 4 is 5. Moving down. 1 and 5 makes 6. 5 and 10 make 15. 10 and 10 make 20. 10 and 5 make 15. 5 and 1 makes 6. So the triangle, right? You have to complete the triangle by adding the two pieces above. So this next row would have a 1. 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 plus 35 is 70. 35 plus 21 is 56. 21 plus 7 is 28. 7 plus 1 is 8, and then 1. Now, how is this useful? Well, if I did x plus y to the 0 power, anything to the 0 power is 1. If I did x plus y to the first power, it would be x plus y. A moment ago, we did x plus y to the 4th power. Okay, I'm not going to rewrite it. Instead, I'm going to bring that piece of paper back, put a little fold in it. One x to the 4th, 4x to the 3rd y, 6x squared y squared, 4xy cubed, 1, y to the 4th. Now, you'll also notice that the powers 4, 3, 2, 1, and then it was gone. The other powers, 4, 3, 2, 1, and then it was gone. And if you'll notice, in each term, that's a power of 4. Power of 3 and power of 1, add to 4. Power of 2 and power of 2, add to 4. Power of 1, power of 3, add to 4, and that adds to 4. So the first thing had a descending exponent, and the second part had an ascending exponent. Okay, so I said we were going to challenge you to do a plus b to the 7th power. But we're not actually going to do it. We're going to use Pascal's triangle because we don't want to do all that multiplying work. So there's our 7th row. So we know it's going to start off as 1a to the 7th. Plus, our next number is 7. Now our a power, since it's the first thing, has to reduce by 1. And our b power is the second thing, so it's going to go up by 1. And if you'll notice, 6 plus 1 is 7. And I'm getting my numbers again from this row right here. So I did 1 and then I did 7, so my next number is going to be 21. My a power is going to drop, my b power is going to increase. Then plus 35, my a power is going to drop, my b power is going to increase. Again, they still add to 7. Then I have another 35, my a power is going to drop, my b power is going to increase, plus 21, my a power is going to drop, my b power is going to increase. I'm running out of room, so I'm going to write below. Plus 7, my a power is going to drop, my b power is going to increase. And then plus 1, my a power is going to drop off, so my a's are gone, and it's all b's there. So if you were to actually multiply a plus b times 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 a plus b, this is what you would get. So think about that. So if you noticed that because it was to the 7th power, we wound up with 8 terms. Anytime you have to expand to a power, you're going to wind up with one more term than your exponent. Let's think about this one. 3a plus 5 squared. I'll solve that. Okay. My squared rule. This is, I'll go ahead and write this down out here, the power. 0 power 1, whoops. 0 power, 1 power, 2 power, 3 power, 4 power, on and on. You might notice that the power matches the number after the 1. Here there's no power after the 1, that's why. So if we're doing to the second power, our numbers are 1, 2, 1. Okay. So from Pascal's triangle, we got 1, 2, 1. Okay, so here our first part is to the second power, then our first part is the first power, and then our first part drops off. Remember, in the beginning we don't use the second part at all, then we do it to the first power, and then we do it to the second power. So again, the first part goes 2, 1, gone, and the second one is gone, 1, 2. And if 2, 1 plus 1 is 2, 2. So now I'm going to simplify that. 3a times 3a is 9a twice. 5 times 2 is 10, times 3a is 30a. And 5 times 5 is 25. So that's using Pascal's triangle. This was just squared, so why not just FOIL it out? 3a times 3a is 9a squared. 3a times 5. 5 times 3a. 5 times 5. I got the same thing. So why not FOIL it out? I wanted to show you that Pascal's triangle does indeed get you the same thing if you want to do it. Now, in this case, like when I did to the 7th power, my numbers matched the triangle. But when I did this problem, my numbers from the triangle were 1, 2, 1, but in my answer I had 9, 30, 25. That's a lot different than 1, 2, 1. Why is it so different? It's because there's numbers inside the parentheses here where there was not before. So we have to make sure we're really careful with that. I'm going to do one more problem, but I'm going to do it vertically because I think that might help some people who are working on Pascal's triangle to think of it vertically and then write their answer horizontally. So let's look at 2x minus 3 to the 5th power. If you look back at your triangle, the triangle numbers were 1, 5, 10, 10, 5, 1. Okay? The first part was 2x. We're going to start it to the 5th power, then the 4th power, then the 3rd power, then the 2nd power, then the 1st power, then the 0 power. And remember, the 0 power is like times 1, so it's really not there. And then we'll have the second part. Now remember, the second part is negative 3. Negative 3, negative 3, negative 3, negative 3, negative 3, negative 3. So since we did 5, 4, 3, 2, 1, 0 on this one, we have to do 0, 1, 2, 3, 4, 5. And remember, to the 0 power is like it's not even there. Okay, so on our top line here, we have 1 times 2x times 2x times 2x times 2x. That's 1, 2, 3, 4 times 2x. So if you were to multiply that all out, you would get 32x to the 5th. Check. Now we have 5 times 2x. There's a second one, a third one, and a fourth one. Then we're multiplying by -3. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 5 is 15. Wait, 16 times 5? Yeah. So that's 80. 80 times -3 is -240, and there are 4 x's. Or multiply the numbers in your calculator. So that gave us -240 x to the 4th. Okay. 10, 2x, there's 1, 2, 3 2x's, and 2 -3's. 2, 4, 8, 80 times 9 is 720. That would be positive. And again, you can double check that multiplying in your calculator. Our next row has a 10 in purple, 2x, 2x, I wrote it twice, -3, -3, -3, 27, 54, 108, so 1080. Sorry, I'm doing math in my head. So -1080 x squared. I've been doing math for a long time, so I hope I have my multipliers in my head. So we have 5, we have 1, 2x, -3, -3, -3, -3. 9 times 9 is 81, 5 times 2 is 10, so 810. There's 4 negatives, so that'd be a positive. And then 1 times -1, 2, 3, 4, 5. So 81 times 3 is 243, so -243. So over here, I just did the work written out of what is written here. So this is my answer. Technically, that's what I wrote at the bottom. The top line plus the second line plus the third line plus the fourth line plus the fifth line plus the sixth line. And this saved us from having to multiply it all the way out. So why use Pascal's triangle? Because doing something to when you take a binomial to a power, you can shortcut that with Pascal's triangle. It does not work for trinomials and things like that, but it does work for binomials, so it can save us some time if we have to do higher powers. Again, you can print out Pascal's triangle. There's a lot of cool things that come in Pascal's triangle. I took a class once called number theory, and we just delved into all the different patterns that come from Pascal's triangle. So if you like that kind of thing, you might go ahead and Google it. It might be an interesting day for you. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.